I am going to finish up the notes from 8.2. So in class today, we got through the state part of our four-step process. So we will estimate the true proportion of the Earth's surface that is covered by water at a 95% confidence level. So then we are going to use a one sample proportion Z star critical value interval. I think in class we called it, what did we call it? One sample Z interval. Any of that is fine. As long as you get in there that it's one sample, that we're taking proportions, or we're dealing with proportions, and we're using Z-star, critical values, you're covered. So our, again, our conditions that we're gonna check, we have a simple random sample of 50 tosses, or you could say, you know, the globe was spun randomly 50 times, something along those lines. For independent, this is what we talked about right before you left. So we could say, because this is an experiment, each toss of the globe is independent of one another. You could also say, assume that there's more than 10 times 50, which is 500, spots on the globe where your finger could land, and that would be totally appropriate as well. If you aren't sure about when to use the 10% condition and when not, the 10% condition can always apply. It's just sometimes with certain situations, it'll feel a little awkward. So if it's an experiment, you can just say that one trial will be independent from the other. And then for normality, we're going to check our large counts condition. So 33 times her finger landed on water, I think. So that means 17 times it landed on land. So because we checked our large counts condition, our sampling distribution of p hat is approximately normal. Okay, so then for do. Okay, I highly, highly recommend that you don't just plug stuff into your calculator. Okay, there are many problems that they will ask you things where you need to understand where your margin of error is coming from. And so if you just go through and you do all of this, then you are covered and you don't have to worry about it. Otherwise, I can show you another example where you could type in the calculator notation, but I want to double check that real quick off the top of my head. I want to double check what will give you full credit and what won't. But I highly recommend that you just write this formula every single time, because then you know where these values are coming from, even if you then just stick it into your calculator. Okay, so the p hat that we got was 66%, and then if you do your formula, you get this confidence interval, 0.5287 to 0.7913. So conclude, we are 95% confident that the interval from 0.5287 to 0.7913 captures the true proportion of the Earth's surface that is covered in water. So the original claim that Jordan heard was 70%. So 70% is a plausible value. It's in our confidence interval. You don't have to write anything about this, but just to take it back to what we started with. It is also plausible that it's less than 70%, but 70% is in that interval. Okay, the last thing in this section that we need to talk about is choosing a sample size so that you can get the margin of error that you want. Okay, so oftentimes we want maybe a smaller margin of error than a larger one, okay, because we don't want these confidence intervals that are super wide, because then they're less useful to us. So if we want to figure out the margin of error, okay, so this is our formula right here, right? The margin of error for p hats is z star times the square root of your standard error, and the standard error is, I'm sorry, I think I missaid that. It's z star times your standard error. Your standard error is the square root of p hat times 1 minus p hat over your sample size. So if you want to determine a sample size to get a certain margin of error, you have two options. Okay, in order to do this, you have to know, well, you have to know your confidence level, because that's your Z-star level. And then you also have to know a p hat value, because we're solving for n. So we only want there to be one variable that's unknown. So one thing you could do for your p-hat is you could use previous experience. Like, let's say that we've known in the past a certain proportion of seniors have gone to the prom. Okay, we could use that value to estimate the sample size that we should choose. Okay, or we could do a pilot study to estimate p-hat. So not do a full-blown simple random sample, but somehow gather some information and get an estimate for p-hat. Okay, if either of those things aren't available or you're not sure, then you can just use a p-hat value of 0.5, and then that would give you a sample size that for sure will give you the margin of error that you're looking for. Okay, so our sample size for our desired margin of error. So we're going to say this margin of error formula is going to be less than or equal to the margin of error that we want. Okay, so p-hat again is our guessed value for the sample proportion, and then the margin of error that we get will always be less than or equal to the margin of error if you take the guess. All right, so for example, tattoos. Suppose we want to estimate P, which is the true proportion of students at Mayfield who have a tattoo at a 95% confidence level, and we want our margin of error to be no more than 0.1. Okay, so we need to figure out how many students we're going to survey so that our margin of error value is no more than 0.1. Okay, so our confidence level is 95%, which correlates to a Z-star critical value of 1.96. We want the margin of error to be 0.1. And let's say I have absolutely no idea in the past how many Mayfield students have had tattoos. So I'm just going to use 0.5 as my p-hat. So you plug all that in. We get our Z-star value is 1.96. Our P is 0.5, and our 1 minus p-hat is 0.5. Okay, so then we get 1.96 times the square root of 0.25 over n is less than or equal to 0.1. It's hard to see, but there is a decimal there. So there's a little decimal there. And so then if you divide both sides by 1.96, I don't have my calculator handy, but it kind of stresses me out that my 1 is gone. 0.1 divided by 1.96. I'm going to have to check that math. I'm sorry. But you get something. You solve this equation or this inequality algebraically, and then you get n for your sample size should be greater than or equal to 96.04. Okay? So you are always going to round up because we obviously can't have 96.04 students, but our sample size needs to be bigger than that. So we're going to round up to 97. So n needs to be at least 97 students. We're always going to go higher. Okay, that was the last little bit from 8.2. So I would recommend, again, that you just check my math here. But this is a general idea behind choosing a sample size so that you can determine what margin of error value you are comfortable with for your confidence interval. And I will see you next class. Thank you. Bye.